So, of course, I want to start by saying thank you, everyone, for joining. My name is Cody Armstrong, and today we're talking about surfacing in Onshape. So, we're going to focus on some of the surfacing tools that we have available to us, some examples where surfacing can be particularly helpful in our design, and really just cover surfacing and the tools that we have in general. As I always say with these webinars, I really encourage you to ask any questions that you'd like. There's a questions dialog, and you go to Webinar Control Panel. Feel free to ask any question, and I'll do my best to stop and address the questions as we're going through the webinar here today. So again, surfacing in Onshape, feel free to ask any questions as we're going through this. I have a few different examples for you, but again, free willing. So ask any question that you'd like. So let's get started. Now, the goal today is pretty simple, and I think that's really to introduce you to surface modeling. Now, if you have a lot of exposure to surface modeling in other CAD applications, bear with me. A lot of what I'm going to cover here, at least at the very beginning, is pretty beginner level for surface modeling, at least as surface modeling goes. If you're new to CAD in general, surface modeling probably isn't the place to get started. At least with Onshape, we definitely encourage you to get started with surface or solid modeling first, build some solid features. But if you need surface modeling, of course, it's an important technique, and that's what we're going to discuss here today. So I have a few different surface modeling techniques, so a few different examples where surface modeling has been particularly important or helpful, and I want to go over some examples of them. And so, where they were beneficial and, where you can use them. Now, the end of this, what I'd like to do is put together a surface mouse. It's just a mouse model that was released publicly that I think is a great example of some of our surface modeling tools. So I'm going to walk you through building this mouse. Now, this is definitely a little bit more involved than a lot of what we do in a normal webinar. So understand that, the surface mouse and some of the techniques that we're going to discuss here are definitely on a little bit higher level than some of, our previous webinars, something like the essentials or advanced. So forgive me now if you're just getting started, really geared towards those that maybe have a bit of time in solid modeling. So that's the rough agenda. Introduce you to it, give you some examples where I think it can be particularly beneficial, and walk through an example of building a simple surface model. So let's get started. Again, feel free to ask any questions as we're going through this. There's, again, a questions dialog there, and you go to Webinar Panel. Feel free to type in any question. So let's dig in. Now, for those just getting started, maybe don't understand or haven't used much surface modeling, maybe heard the term surface modeling, but don't really get what's the difference between what I'm doing today and surface modeling. It's important to point out what most users are doing today is what we refer to as solid modeling, and that is, creating solid, sometimes referred to as watertight models, and that is clear boundaries, no gaps between faces, and so on. And that sounds very simple, and if all you've ever done is solid modeling, you would say, oh, of course, that's the way it's intended to behave. But there is a technique referred to as surface modeling, surfacing. And, the example I often give is, think of it instead of in terms of features, but building a face at a time. And if you think of a model as a composition of faces and not a single feature, so to speak, then, you start to understand the surfacing logic. So just keep in mind, again, it's a bit of a different philosophy from solid modeling in how you think, how you might construct something. But there are a lot of users out there that like to think of, solid models as a composition of faces. And those types generally lean towards surface modeling in particular. Now, again, think of it as modeling one face at a time, but of course, with our extrude, with our revolve, there's ways to construct multiple surface faces, of course, with one command. But again, think of, the general modeling technique as one face at a time, and you're building the faces to create your model. Now, I will say with most MCAD users out there today, the goal is still to create a solid model. Your goal is still to finish with a solid part. It's just a different technique to get there. Now, of course, the key thing with surface is to keep in mind it has no thickness. And I think, if you have a lot of experience, that sounds kind of obvious. But for those new users out there, a surface, think of it as, a sheet of paper, so to speak. It has no ends. It has no thickness whatsoever. It's a face. And so, the examples I often give, it's useful for creating complex shapes where I need to take a combination of faces and bring them together and then later turn that into a solid part. But it can also be useful for construction, and that's what a lot of what I'm going to talk about here today. So I have an example where we build a mouse, for example, a little bit more complex shape defined using nothing but surfaces, but also realize that there's a lot of great examples where you just construct a simple surface for construction. Just to extrude up to, or to reference in your sketch, or to, there's dozens of examples I can give you where users will create a surface just to have it as a reference. So, what is surfacing? Again, simple explanation, I know, and forgive me for the simplicity. There's a lot more detail we could get into, but for time's sake, I think keeping it simple is important. Let's get into the basics. Now, where can I use it? Anytime you need a face for construction. And the example I'm going to give you, I have a few different examples where it's beneficial to not just construct maybe lines, but have an entire face or a surface associated with your reference. And I have a few examples of this where you can't get away with using sketch geometry as your reference, where a surface becomes necessary to define an end condition, perhaps. So, construction, I think, is a great use case that I think a lot of users today just aren't aware of. A lot of users today we talked to didn't realize we could create surface models at all. So, a big part of today is just introducing you to how you create it. But realize you don't necessarily have to be creating, 500 and 600 feature parts to justify using surfacing. You can just use surfacing as a simple construction tool. Now, one of its biggest use cases out there is the more complex features where I need, shapes that aren't as easily created using solid modeling. So there are a few different examples that I'm going to discuss that kind of drive home both of these concepts. And I want to start with kind of the basics. So let's jump into it. Now, I want to start with the extreme basics. So forgive me again if you have a lot of exposure to Onshape or surfacing in general. I want to cover the kind of basics of getting started. Now, again, a lot of users out there weren't aware that we had some of these tools, so I want to point out where you can find them, and that's the first thing I want to start with. So let's say, for instance, that I wanted to take this line and extrude it into a surface. How would I go about doing that? I'd select Extrude, and here's the important step: click Surface. So Extrude, Revolve, Sweep, Loft all have this option for surface. And of course, when you change to surface, you have the option to click on sketch curves that you want to extrude. This allows me to not define a face similar to this rectangle, but an open contour like this line. And it takes that one line and extrudes it as a surface. It's important to point out surfaces appear in the feature list on the left. So you'll see surface 1 shows up here. I can hide and show it as if it were a part, for example. So again, it behaves very similar to solid geometry that we create. So that's a basic surface extrude. Now, any of these features can be extruded. So I can click Extrude, Surface, and for instance, click on the curves of this rectangle and extrude all of those. Okay. And again, driving home the idea that, again, this has no thickness. So think of this as this rectangle is essentially 4 faces with 0 thickness in them. So just keep in mind, as we're doing this, that very common in thin profiled parts or parts that have an even offset, it's easy for me to thicken this and create, a hollow box, for example. So that's surfacing and the extrude feature. Again, very simple. Just click on the curve that you want and it will extrude that curve. Okay, but you can do a lot more than simple extrudes, of course, and I do want to point out a few other features. So, of course, revolve works in just the same way revolve works at the solid level, right? I click surface, I define the edge that I want to revolve, the axis I want to revolve around, and I have my surface part. Now, at a glance, of course, it looks, at least from the outside, to be solid, but it's not, of course. And if I were to do something like a section view, you can see that, of course, it's not a solid part. Okay, so again, surfaces have no thickness. So that's a simple revolve. Now, of course, we also have commands like sweep. So I can take this open contour, in this case a single simple line, and sweep it. Sweep surface, click the line, then click the path. Questions. Is there a separate way to use surface to directly trim a solid? Using split requires multiple steps and is a bit counterintuitive. Split is the command. I'm not sure the multiple steps. I'm going to show you an example of split in just a second. But if you want to manipulate a solid based on a surface, split is the command to do so. Okay, so that is the surface sweep. Another question, real quickly, can you knit separate surfaces together? Forgive me. The answer is no. We don't have a way to combine multiple surfaces into one yet. Now, of course, we have Boolean operations for solids, and I'll show you an example of that. And we can take our surfaces and thicken them, but we do not have a way to combine two surface parts or bodies as of today. So that is a surface sweep. Again, taking an open profile, in this case a simple line, and sweeping it along the path. So let's delete that one. My final example here is, of course, the loft command. And the surface loft has a lot of power. And in general, our loft command has a lot of power, especially when we start talking about matching curvature or surrounding geometries. A question that's come up, is it possible to create a surface bounded by four curves? And the answer is yes. I'm going to show you an example in just a bit where we can use the loft command to drive a loft between two curves and use the boundary curves as guides. And so the loft command in general is one of the more powerful commands that we have in Onshape, and definitely worth getting into detail if you do a lot of that type of modeling. So here's a simple example. I want to loft from a square to a round, but remember, we want to create a lofted surface. So I'm not transitioning from this square to the circle, I'm transitioning between edges. So I select loft, surface, and I select edge, edge. Okay. So again, the reason I bring these up is these are all examples, and I think a lot of users have seen in solid modeling, just realizing that it's very similar. You know, I'm creating, if I hit the green check here, a lofted face between those two edges. Now, if I wanted a closed loop, I can, of course, do that. I would need to do a few more lofts here, but I can easily do that. Edge, edge, and it lofts between those two edges. So, again, just trying to drive home the idea that it's a very similar workflow to solid modeling in many situations, and you don't require a separate dedicated set of tools for it. Right? So, loft between these two, and now I have a lofted squared around transition. Okay. Also, a very neat way to control the transition between contours, because of course the points align in my loft. Question, is the surfacing in Onshape designed to replace something like power surfacing? And the answer is no. We are not at that level of power surfacing capabilities. So just keep that in mind. You know, if you're looking for the most robust surfacing level capabilities, power surfacing is definitely something to check out. Questions. Lofts are sometimes okay, but really the bread and butter are boundary surfaces and fill surfaces with tangent and curvature continuity. Will you be showing those today? I do have an example of matching the curvature. Yes, I do. I also have examples where you can use the loft to fill surfaces. So just bear with me for a bit. Question. So you split the circle first. That seems like a bit of a long process. Why not square to circle? And the reason that it's split is because, remember, I'm not lofting. This is a lofted surface where I'm lofting from edge to edge. I can't loft from four edges to one circle as a surface loft. Now, as a solid loft, that would work just fine, and you could do that. Just click the two faces and you have it. But I wanted to illustrate the idea that in a surface loft, you have edge to edge. Any examples of using Thicken surfaces to later be flattened? I do have an example of using Thicken, so bear with me. In the loft example, is it possible to define the continuity between surfaces? There is an option in loft to define matching tangency or continuity. You have curvature continuous options and then matching tangency. And I have an example of that in just a second. Can you control the curvature from one shape to another? Absolutely. If you're not familiar with the concept of a guide, I would definitely check that out. We've done a separate webinar on the loft command, and it discusses guides in greater detail. So if you're looking for just the loft command, I would definitely check out that webinar. Question, can you just pick all the edges rather than doing 4 separate lofts? Remember, that was 4 separate surface lofts. That if I were doing a solid loft, it would just be one face, and I would click on 2 things. So, is there a way to derive a surface object from a solid? You cannot convert a solid into a surface object, but you can use it as a reference for constructing one. And I have an example of that in a second. Is stitching surfaces a priority? Absolutely. I would say that there are quite a few tools that are high priority for us in general. Sheet metal is probably very, very high on that list for users, but surfacing is also very, very high on that list. So, things like the ability to stitch surfaces or boolean surfaces together is very high on our list of priorities. Now, I will say that the solid modeling is all there, so I can convert this to a solid and, of course, boolean that together. Question, can you constrain the starting loft and boundary to be normal to the profile? Yes. And so we're getting a lot of questions on the loft definition, and I do want to get into this in greater detail. There's 2 things that I wanted to show. First, guides. The question came up earlier. Is there a way to control the curvature from one shape to another? The answer is yes, with guides. And I'll show you that in greater detail in a second. But we also have end conditions. So I can say that I want, the start and end to be normal to profile for a longer period of time. Right? Normal to profile, and you can see it will manipulate that loft definition. So you do have end conditions that you can specify in the loft for normal to profile, tangent to profile, but also, and I think for a lot of users, I see a few questions on it already, matching tangent, matching curvature. These 2 will allow you to match surrounding faces so that you have a smooth transition from your loft into a surrounding face. And just jumping ahead here, just because of all the questions, so bear with me. I have a simple example of this where I've lofted from a circle that was split in the face to a circle above it. And the reason I bring this example up is 2 reasons. First off, the split command can be used to split this face. So this was a continuous face where a circle was sketched, and that circle was used to split this face so that I can easily loft between them. Now, the split is one important step. Also, of course, you have to construct the second loft profile, which is just this simple circle. But the other important step is defining matching curvature in the actual geometry. So if I edit this loft, the end condition is defined as match curvature. And what that will do is it will match the surrounding geometry so that I get true continuity between these 2. Now, there's also a match tangent, so it depends on the level of blend, so to speak, that you need between the faces. But keep in mind, this option will allow you to match the surrounding contours. Okay, and I just bring this up now. I was planning this for a little bit later, but I think that a lot of users out there are asking this question: how do I match my loft with some other face that I'm creating it off of? And the answer to that is match curvature. Okay, so definitely check out match tangent, match curvature if you're trying to blend your profiles, your loft, with other commands. And I think a lot of users out there are familiar with commands like boundary, for instance, that has these options to match tangent curvature. Ours is built into the actual loft. Okay, so that is match curvature. I'm jumping ahead just a bit, but I do want to point out it is an option in the loft command. Now, I've shown you all the basics. So, a simple extrude, you can take any open profile, you can sweep it, you can revolve it, you can loft it. Just keep in mind, we're not working with faces, we're working with edges. And that's the key difference in these situations. So let's go over more than just creating the basic shapes. Where would I actually use this? And I think for a lot of users out there, you may not construct something entirely from surfacing. You may use a surface here or a surface there, and in conjunction with solid modeling techniques. It's often mixed modeling, what's referred to as mixed modeling, but it's just using the tools that you have to create the geometry you need quickly. So a good example I always like to point out is the fishing reel and the power drill. And these are examples of models that were built entirely using solid modeling techniques, but using surfacing for construction purposes. And so, you can create a surface that's only there as an in condition or as a reference for your sketch or as a reference for a sketch plane. So there's all kinds of great examples of it. Now, this is a power drill with, something over 300 features. And it has two surfaces that were there solely for the purpose of construction. And the one I really want to focus on is this surface 1. So surface 1, you'll notice, matches the curvature of the grip of the power drill. And so if I click it, it says Extrude 3. So this is Extrude 3 in my toolbar. Let's roll back to here. So I'll right-click Extrude 3, and we'll roll back to this point. So if I roll back in my design, you'll see that, of course, we have much fewer features here. This is a much rougher power drill. But the reason I bring this up is the purpose that the surface has. The reason this is here is just so that I can extrude this up to that face. Because if you think about it, if I want to take this geometry and extrude it, and I want to match the surrounding curvature, I want to match the curve of this grip, how would I do that? Right? I can't click on the edge of the line as an example. I can't use sketch geometry as an example. But a surface is a perfect example. Right? I construct a surface and I just say up to that face. So, real simple. It's just a basic open sketch. So if we take a look at sketch 17, you'll see it's just a simple 3-point arc. Right? That 3-point arc is then extruded. So you'll see surface extrude. I'm not overly concerned about the depth, and that's something that's a bit different from solid modeling. You'll see that I'm not concerned about overall is this exactly a certain amount. It's only there for construction, right? As long as it's wide enough, so to speak. So in this case, I've defined the depth as such. Then I can easily take extrude, grab the face, and then say, okay, I want to extrude up to face, and then use the surface as my reference. Right? And so now I can grab both of these faces, extrude up to that surface, green check, and now I have my feature. Right? So again, the sole purpose of the surface was just there to construct an in condition for my extrude. Okay. Question: can you extrude up to more than one surface at a time? You can extrude up to one surface. If you have several combining features, I believe you may be able to select them, but they would need to be honest, I don't have to test it. I believe they would need to be touching each other, so to speak. I couldn't have disjoint surfaces, so to speak, as references. And it would depend on the in condition as well, where the direction of the feature is going. So, real simple example, I know, but I just want to point out, this is a great example where surfacing has solved the problem that I was struggling with in my solid model. And so its real purpose is just for construction, but it's a very useful tool in that. And again, when I rebuild my model, if we roll this back down to the end, I don't have to see the surfaces. I can hide them. I can delete them. You can delete them, by the way, and it will not break, so to speak, the model. It does a delete part very similar to deleting a solid model. But just keep in mind that, you can create these surfaces that are just there for in conditions. Or, we know a lot of users out there create a surface just to define the depth of their thread, for example, because they like controlling it that way. Surfaces are ignored it can be ignored at the assembly level. So keep in mind, you can, just insert just solid parts. You don't have to see this face, so to speak. And it's just a neat way of solving a problem like that. Now, another example I like to point out, and this is where I'm using surfaces to construct essentially angles and differences between faces, sketch planes, so to speak. And so here I've got this fishing reel assembly. And if we jump over real quickly to the finished thing, there's a lot of complex faces at different angles in an example like this. So, this is a spool that rides up and down on a thread, and the actual end pieces and all these various things, have varying angles, compound angles, right? So this is rotated 15 degrees from this axis and down in the y-axis by 10 degrees, so you have a combination of things. And that's another great example where I can construct surfaces just to reflect the relationship between parts. So here's that same spool, and it has a few important bosses. And I want to be able to construct maybe a loft between the two bosses, or maybe a sweep between the two bosses. And surfaces give me an important role there, right? I can click on an edge, for instance, and define that as the guide for my loft, or the profile, the path, for my sweep. So just creating these surfaces, extruding them, you'll notice they're just extruded to any depth. They're just there for construction, so it's not critical the depth, but they're there just to help me figure out, okay, what's the relationship of this part to this one, and allow me to set the angle, of that accordingly. So an important one, again, they can serve as references for end conditions. They can help you construct angles that are relative to each other, or help you construct relationships to parts that are relative to each other. All kinds of very neat examples, and all of these so far, again, are just used for construction. I'm just focusing on these surfaces aren't a part of my finished part. They're just there to help me finish or build my solid bottom. Question: can you trim the surfaces to each other? You can split the surfaces and then later delete, and that is an option, but do not have a specific trim function. All right, so let's move on. Now, I mentioned before, using surfacing as construction is a common technique, and both of these examples I've shown you, they were created to help me finish my solid model. But surfacing is actually a technique that you can use to build the solid from scratch. And I think a lot of users that are familiar with it, that like that workflow, want to know, what would I do in Onshape to accomplish this? So what I'd like to do is show you an example of the mouse, a simple surface model mouse. And just jumping back real quickly to my slides here, there are a few reasons I like to point out this mouse. This is a public model, so I want to say thank you to the person that created it. And it goes over a few great surface modeling techniques: extruded surface, lofted surfaces, split, and thicken. Now, this will take a bit of time, even to create a few features, so we're not going to be able to totally finish this mouse, but I will say that I'll publicly release this model. So if you do a search for webinar mouse at the end of this webinar, I'll make sure to make this public, and you can take this model, copy it, and take a look at how it was constructed. So what I'd like to do is walk you through how to get started doing something like this. How would I start constructing, those kinds of shapes? Now, I'm not going to worry about creating the exact contours that you see here for time's sake. We're just going to keep this quick. But how would I create something like that? How would I create those kinds of shapes in Onshape? Now, again, a few steps, so please bear with me. There is quite a bit of sketching in this. Let's start a new document up. And we'll create an example mouse. Right. All right, so I'm just going to create a new document from scratch here to have a blank slate, and we'll start creating the basic geometry that I want for this. So I'll start on the front plane, and I'm going to sketch first a construction line through the middle, and I want to make this line midpoint to the origin. So we'll make those midpoint, and I want to line with, let's say, and this is the overall length of my mouse, so to speak, so let's say it's 2.5. I'm just making these dimensions up, so please don't go out and make this mouse. It may be very big. But I want to construct the outside profile next, so I know the overall length of it. Now I want to construct kind of this shape that I want to drive this with, and there's a few things that I want to point out. First off, the spline command. If you haven't used it yet, I would definitely take a bit of time to get the feel for the spline command. But it's really just a matter of clicking points on each of the profiles, or each of the places that you may want to manipulate that spline. So I've constructed a simple profile here. Okay. And what I'd like to do, let's go ahead and close out of this one. I'm just making small changes here. Okay. So I've created this kind of outside profile. Let's hit the green check. So that's my first sketch. Now I want to create another sketch, this time on the right plane. And I want to start with 2 construction lines that go vertical from the ends of my past sketch. Right. So I've sketched 2 construction lines. I want to attach the ends of these lines to my past sketch. Right. So left click. We'll choose coincident. Right. And I'll do the same thing over here. And you'll notice this is a common theme throughout the design of this. We must attach these sketches to each other, either using pierce or coincident like I did there. Now I can add a few basic dimensions. So let's say this is 0.75, and let's say this is 0.5. And now I want another contour between them. All right, so I'm going to create a second sketch here. A second spline just between these 2 points. And I don't need multiple points in the spline command, so I can just go point, escape out of spline, I'm done with it, and then grab the handles of the spline to manipulate the geometry and get what I'm looking for. So just keep in mind, you can just have 2 points in your spline and just use the grab handles. It's a very effective way of getting the contour you want. It also gives you the smoothest curvature. If I have multiple points and it creates, ridges, so to speak, in the spline, 2 points gives you the smoothest transition. So I have this spline with 2 simple points. Now, both of these sketches, I'm going to accept this, are solely there for construction purposes. So what I'm going to do here is I want to take both of these and just extrude them. So extrude surface, we'll go here, up, that looks good. Extrude surface, we'll extrude this out. So again, all I'm doing here is extruding these 2 splines in either direction. The important thing that I want to get from this, the important thing I want to point out, is the intersection between the 2. Because now I can use the intersection between the 2 as a profile for my loft, for example. Remember, you don't have to have planar profiles for your loft. So I can loft from a flat, edge to a, 3D contour like this. Now, one big tip that I have is you can take this contour and split it because you need an edge, so to speak, to reference. And so this is where this split command comes in handy. Now, just keep in mind with the split command that it's going to manipulate the contours, but it won't delete pieces of it. And so just keep in mind that would be a separate step, but very easy. Part of surface that I want to split, well, I want to split this, and we can split it with that. Right. And now in my case, it's going to remove the original. I can check keep tools, and that will keep both surfaces. But more importantly, it splits them so that I have this nice edge. Let's go down here to define along. Right. So there's the edge that I can use for my loft. Right. So just another technique, but I'm just using those first 2 extrudes to create that 3D contour between them that I can then use to loft between. All right, so a few questions that I see. Do you have curvature comb display? We don't have a curvature comb specifically, but we do have the ability to turn on curvature analysis on the 3D level. That is an option in the View Cube menu. Do the spline handles represent any specific metric? No. It's a, I believe it would be the scale factor of I forget the exact term, so forgive me, but it's not a specific metric. Can you demonstrate tangency, normal, and curvature endpoints on conditions in your spline? Can you create greater than G2 curvature continuity in your spline conditions? You can define tangency to other things. Continuous curvature, the tangency would be the closest thing I could think of off the top of my head. And you could, of course, construct straight lines, for instance, and make your handles tangent with those things. So a quick aside, bear with me, those that are waiting for the next step. I can make this point and this point vertical or horizontal, or tangent to another line or tangent to another piece of geometry. So you can constrain the end point of the spline and the end of your handle to things. I could make this horizontal, for example. And so that's an easy way to make sure that my transition from the spline to the line is tangent. Question: can you make a projection curve without having to go through all these steps with these surfaces? No. Today we extrude the surfaces up to each other. Now it has been brought up in the past, kind of a composite, bringing the two curves together. But as of today, generating that edge would be done using the technique I showed you. Question: can you dimension the spline handles? Yes. So real quickly, if you need to, you can dimension the spline handles. Can you extend one or more edges of a surface? No, there's not a specific extend or offset kind of capability today. All right, so I've constructed these two surfaces. I've split them so that I have this one edge that I can loft between. Now, I actually want to create a separate contour for the edge of my mouse. So in this case, let's just hide a few surfaces here and turn on a few sketches. What I want is a similar contour what I sketched a moment ago. You can offset splines, by the way, so if you really want an exact transition between shapes, you could do something like an offset. In this case, I just want a simple spline. Now, just like every other example I've shown you up to this point, you want to make sure that it's attached to the previous sketch entities. So I'm going to make sure that these endpoints are coincident to the lines, and we should be good to go. If I need to, I can make any small changes here, but in general, that's just fine. So I have that as my loft profile. Okay? So essentially what I'm looking for now is a loft surface between this edge and this geometry here. Okay? Real basic. So again, I'm using the edge of the intersection between two surfaces and the offset of the spline to generate my loft. Real quickly here, let's hide the other surfaces. So that would be my finished loft profile. Okay, so just pointing that out again, creating a loft is very simple. You can even use these 3D contours like this as a reference for your loft. Now, I also want to point out the idea of what we call guides, and guides allow you to control this on an even finer level. So let's take this one step further. Let's say that I wanted to control the transition between shapes a little bit more accurately, for example. Well, I can construct guides on the ends of this. And so let's just say I wanted an arc transition. So let's do a 3-point arc between the end point of this loft profile, right, and the end point of the other loft profile. Now, I'm not overly concerned about the dimension. Again, this is, if you're spending a lot of time, you'll probably want to spend the time to fully define everything. But in general, the surface dimensions aren't quite as critical. Forgive me those that do a lot of surface modeling and don't care for that. But again, just, driving home the idea, very simple. I create, 2 endpoints there. I have my radius that I want to control the transition between the contours. Okay, let's do this one more time. I'll do 3-point arc. This time, same thing, but on the opposite end. Okay, and make sure, again, to attach my endpoints to the previous sketches. That's a very important step. I'm using the coincident constraint to make sure these arcs are actually attached to both loft profiles. So that's 2 of them. Now, I'm going to do one more, this time on the top plane. All right, so select top plane, sketch, and again, simple 3-point arc from here to there, like that, and then attach it. Now, here I don't have as easy as an option. I can select the point, but in this case, I want to make it pierce with where this spline passes through my current sketch plane. So I can select this, create a pierce, and that joins the 2. All right, here, coincident, or excuse me, I made the mistake there. Here, pierce. Remember, there's no point there, so it's where this contour passes through my sketch plane. And now let's make a small adjustment here, make this just a little bit bigger of an arc. All right. So now I've defined 3 guides and, of course, 2 loft profiles. And, of course, this is when you're looking for the utmost control over the shape of the part. But now I can go in and create my loft. All right. So let's loft between surface 2 right here and this profile. Then I want to add guides of these arcs. Notice as I add the guide, the loft is then manipulated or adjusted to match that profile. Left click, notice that it extends out to match the arc of the mouse. So left click, green check. There's the first loft for constructing my simple mouse. Right? So just getting started there, but I wanted to point out again, using in this case several different sketches to construct both the loft profile and the guides for that loft. Question: can you have Onshape automatically create constraints? It's important to point out most of your constraints are automatic. I'm doing a lot of things that are on different sketch planes and so on. But if you're doing sketching lines and circles together, they're all going to snap together with automatic constraints, because it's not going to constrain automatically to a 3D contour that's passing through that sketch plane. So in that case, I will need to manually constrain it. But many of the constraints in Onshape are automatic. Okay, so let's move on. Now, the next step that I'd like to do here, bear with me for just a second. What I'd like to do is construct kind of the top piece, the upper piece of this profile. So we have a few basic shapes constructed. What I want to do is start creating the top half of my of my mouse. So let's do that. Now, in this case, let's create first a sketch on the right plane. All right, so sketch on the right plane. I want a construction line going through the middle of this, just to define the center. And then I want a 3-point arc from the end of the surface up to that construction line. Okay, so there's one. I'm going to do the same thing here. And I want to make sure these two are, of course, tangent. Now, what I need to do is attach the ends. So we'll attach the end here to the end of my surface, and we'll attach the end here to the other end of my surface. And again, these are just using coincident constraints. So now I have the transition for the top piece, so to speak, of my mouse. That's one of the contours. Green check, so that's one sketch down. The next sketch, this time top plane, very similar thing, except I want the other direction, right? So similar concept. Let's start with a construction line, right down the middle, and construct 3-point arcs from here to there, like so. And of course, I want to attach this as pierce to the geometry. There we go. Now, what I want in this case is a second arc going the other direction, but I don't really have anything to attach it to as of yet. So I'm going to constrain it as much as I can. I'll make this and this tangent, right? And I want to make this, this, and this symmetric. Okay? So that gives us the symmetry that we need. Now, if I wanted to, I can add a simple dimension, let's say 1.5, and that would define the contour. Okay. The reason this is so important is now, if I hit the green check, I want to create a surface that's bound by all of these edges. And that's a question that I get asked often. Can I create a surface that goes, between all of these edges? And the answer is yes. You can use loft for this. So I can select loft, surface, loft from this edge to this edge, and use the other one as a guide. This other transition as a guide. Now, make sure, there's the mistake I made, make sure that the profiles are touching. So this is a mistake I made here, but I need to make sure that this sketch is attached to this sketch. And you can see there, as soon as I clicked loft, it failed. So let's edit this sketch, and let's delete this and constrain it rather by this profile. Okay, there we go. So now, one more time, loft, surface, from here to here, and guide of this. There we go. Okay. And so now it's matching the guide. I'm lofting between these two profiles. Even though these profiles share an endpoint, it works just fine. All right, loft there. I can do that one more time. Loft surface. Let's turn those sketches back on. And let's loft between them. Okay, loft, loft. And we will use guides, same edge. Okay. And so now I'm creating kind of the top pieces of this profile. Questions. What was the purpose of the symmetry constraint? I want to make sure that the radius is equal on both sides and that the endpoints reflect that. You can do that a different way. I could have dimensioned it, for example, and accomplished a very similar thing. The big thing is I wanted to make sure that I had a tangent transition between them and that the transition between arcs was equal on both sides. All right, so in this case, I've now created, all of these lofted surfaces, right? The lofted pieces for the top half of my mouse, the surrounding pieces. Now what I'd like to do is mirror this to the other side, right? So I can choose the mirror command, and we'll select all the surfaces as the things that I want to mirror. The mirror plane, in this case, will be the right plane, right? It mirrors it to the other side. Green check. And now I've mirrored all those surfaces. Okay. Now, what I need to do next is, of course, create a closed profile to this. I need to create a bottom to this mouse. And to do that, what I'm going to do is create a sketch on the front plane. And all I really want to do here is draw two lines. One line from the origin to one end, and one line from the origin to another end. Then I can attach the ends. Again, very important, attaching the geometry to the edges of your part. Let's hide this sketch. Point, point, coincident, and let's hide this over here. Point, point, coincident. So now I'm attaching this line to the ends of the part. Now, what that allows me to do, turn on sketch 9 here, is loft between those lines and the edges of the part. Right? So loft, surface, line, edge, and I get a loft between them. So again, you can use, even though in this case the boundary, one of the loft profiles touches another, it works just fine. I can loft between those. And I think a lot of users, if you're looking for a way to cap a void or a surface or something like that, this is a common workflow. Define one contour, another, loft between them. If you need to specifically control it with both directions, you can use guides on either end. So again, real simple. Profile, constructs the loft. Now, we've discussed a lot of lofted surfaces. We've discussed a lot of extruded surfaces. We've even discussed things like splitting a surface. But again, the end goal for a lot of these surface modeling techniques is still to create a solid model. And so the question often comes up, well, then how do I transition this into a solid? And remember, it's going to be a solid with, a shelled part. It's maybe injection molded, whatever the scenario may be. I need to be able to thicken it to create a solid model. So let's discuss that. Now, real quickly, I see a few questions that I've missed. Questions. This works on up to 4 edges, right? Can it be more than 4? You can have as many guides as you'd like. You're lofting between 2 edges, but you can have as many guides within that as you'd like. What exactly defines a guide in a loft edge? Well, it's really more of what you click on, in the examples I've shown you up to this point, it's more of how I define them. They're in 2 different boxes, so to speak. In some situations, they're almost interchangeable. In some situations, I do want to stress that, not all. So the examples I've shown you, in some cases, they could be interchangeable, but in many situations, it's the guide manipulates the transition from one contour to another. Questions: are those really trimmed 4 side surfaces, or did you just make a 3-sided surface? No, these are 4. Well, in this case, these are just 3-sided. You're correct. So 1, 2, and 3. Can you select multiple question: is there a shortcut key, or can you set up a custom shortcut for coincident? All the keyboard shortcuts, by the way, are available. You can see them if you mouse over them. So if I mouse over coincident, you see the little I next to coincident in that flyout menu? That's the keyboard shortcut. So coincident is the I key on your keyboard. Okay. You'll see me use some keyboard shortcuts, but I do like to avoid them just to drive home where the commands are in the interface. Can you select multiple edges as one in condition in loft? No, what's important to keep in mind is one edge. So one edge, and that's what you're lofting between. Now, a solid loft, you can loft between faces, right? So it can be a combination of things, but a lofted surface is between 2 edges. Question: is there a zebra stripe tool? We do have something very similar. So if you're familiar with the zebra stripe command in SolidWorks, we have a command under the drop-down menu in the far right, the little view cube here in the far right. We have an option for curvature visualization, and that will turn on the quote-unquote zebra stripes. Question: how can you find the parting line along the sides? I've seen a lot of techniques for this. I would say constructing a surface to represent the parting line and using that as a reference is a common technique. I don't exactly have any parting line examples to show, but I will say it's a common technique, using the parting line to construct a surface as a reference for other things, maybe splitting the part, for example. Question: 3 sides converge to a 0.1 corner, which is considered really bad practice. Forgive me, I'm not sure exactly what you're referring to there. You can loft to a single point. A point is an accepted option for loft, so I can loft from a line to a point, for example. Okay, so moving on, I want to get into converting this into a solid. And of course, the key tool to taking any surface model and taking it and converting it to a solid is the thicken command. It's really the last thing I wanted to mention here today. You take a surface and you thicken it. And it's pretty straightforward. So I can select, for instance, a face, right? Define the amount that I want to offset, okay? And it will thicken that. Okay. Now, in this case, it's thickened it up, so let's hide all the surfaces. And there's our thickened surface. Now, it's only 30 thousandths thick, but this is, maybe it's an injection molded part where it has, kind of that uniform thickness. So in this case, that's really all there is to it. You can take and grab the surfaces, convert them with thicken. All it is a matter of defining the amount of offset that you want. So a few questions. Would you mind explaining the use or purpose of curvature visualization? The idea behind it is a lot of users are concerned about sharp transitions in curvature, and curvature visualization will show you those sharp transitions. So when you see a drastic change in curvature, you'll see a drastic shift in the zebra stripes. If you see a lot of, very close comb, so to speak, a lot of close zebra stripes, you have a very sharp transition in the contour. So it's really about defining the connection between 2 faces and how smooth that connection is. You've heard the term continuous curvature, and the idea behind that is having a true continuity between faces. This is all very important when we talk about using, or when we talk about aerodynamics or ergonomic shapes. Maybe it's being held in the hand. Those are types of things where the curvature is very, very important. thicken with surface will not give a solid, and this is a very good question, good point, I should say. The thicken command right now, as of today, is thickening individual surfaces. Now, I can then, I've seen a lot of techniques for converting using like extrude up to surface, for example, but I can't take this and just say convert this to a solid, and that's something that we're aware of and definitely working on. But I will say you can take, the individual surfaces and start to convert them. So, let's do this real quickly here. I have a few surfaces converted. What I'd like to do, let's get a few more done here. Let's thicken this one. Same thing. 30 thousandths. Reverse it. And then let's thicken the outside. Okay, so let's show everything and just grab these two here. Now, the reason I'm going through the effort, thicken. There we go. Now, the reason I'm going through the effort of thickening all of these is I really want to drive home the point made earlier is, okay, I want to convert this into a solid. Now I've got 5 parts, so let me hide all my surfaces. So there's my, actually 6 parts, 1, 2, 3, 4, 5, 6, and now I can take and boolean these together, right? So I can say, okay, let's take a simple boolean operation, do a union, and join these features together to make one. Okay, and so now that's one solid profile. Okay. All right, so question: can you fence or select components you don't have, so you don't have to do each separate surface separately? No, it's important to keep in mind with a surface loft, it's between one edge and another. Okay. Can you create a solid by fill in for all the volume bounded by the surfaces? No, that's something that's very high on our list of priorities. Thicken to a solid, or recognizing enclosed volumes is important. That is something, by the way, that's very high on our list. I would say, in general, our surfacing tools are very, very high on our list of priorities, building new functionality into them. Can you patch surfaces? The command I would use in that situation would be a loft, and you loft between them. Could you overlay a solid block on this surface and then split the block with a surface model? Yes, you can split with a surface model. You can also extrude up to the surface, and that would allow you to convert this. And that's the common technique I've seen. If you have an enclosed volume, do a convert or even an intersection curve and extrude that up to surface. And of course, you end up with that. That doesn't work in all situations, but it is an option, especially in an example like this one. Rather than thicken, is there a means for making a fully solid? Again, the technique I would use there would be to do something like an intersection and extrude up to, or actually go in and fill in those surfaces using regular extrude commands, for example. Up to surface can be a powerful one if I have all the shapes defined in the surfaces. Question: can you combine surfaces? No, this was asked earlier as well. There's no way to boolean or join multiple surfaces or knit. I know that's referred to in SolidWorks as knit. So I don't know if you have time today, but notice all your surfaces creases at the mirror plane. Can you go back through and redefine the splines and resulting surfaces to make sure they're normal to the mirror plane to eliminate these creases? Is that possible? Yes. I can go through and define these actual splines, and I should do it with the splines we defined earlier. I could make this, an example I've commonly seen is, I draw, let's say, a horizontal line, and I would make, this transition horizontal, right? Point, point, point. I can say horizontal, and that will ensure that I have a smooth transition from the spline into the line. Okay? So that's one way that you could accomplish that. Could you add a setting as you thicken to make into one part? Technically, this would be something possible with a command like feature script. You could build a feature, but it's not out of the box. There isn't a command that will automatically join all of them together. It would be a separate Boolean step, separate command. But it's just a matter of window selecting and joining them. If I want to compare a model to a real world 3D object, is there a way to 3D scan an object surface and import it into Onshape? You can scan a model if you have a resources to scan and then import. We support STL and OBJ, and those are very common formats. So if you're looking for that, you want to make sure it's in OBJ or STL format. We can also import pictures. I don't know if that's helpful for you, but you could import several pictures and use those as references in your sketch. Guys, I'm almost out of time, so I want to say thank you, everyone. I know there are a few questions, so I am going to stick around and make sure all the questions are addressed, but I don't want to take everyone's time doing it. So I want to say thank you, everyone, for joining. Again, stick around if you have outstanding questions. I will make sure I get to them. But I want to say thank you, everyone, and have a good day.